Today we're gonna try plotting a histogram. A histogram is very powerful plotting. It's used in different aspects in different sectors, whether finance, engineering, college students, statistics, calculus 3, all of this require histograms or has a histograms. So let's begin. As always, I have to specify a data. This time there's gonna be something. I love MATLAB, how like he always like write description. Randn, normally distributed random numbers. And this is the function we're gonna use, especially with the histogram. And I'm gonna just say what this means. And let's make our vectors from 1 to 1000. So what's the random distribution random numbers? So basically, random numbers is just like a quick recap. Random numbers give me three things. It makes sure that the histogram are centered at 0. So we're gonna see like the center of the histogram will be at 0. So it is in the middle. Okay, this normal or like, yeah, it's normal distribution. And also symmetrical. Symmetrical, it means like it does looks like a bell shape, like going up and then going down, and we're gonna see it once we like actually plotting it. And the third thing, the x-axis will range from -3 to 3. Okay, so let's write this real quick. So it's symmetrical, and it does ranges between 3 and between -3 and 3. So that's why I have to use like normally distribution random numbers. And what means by 1 and 1000? This means basically that you are telling MATLAB, okay, please create for me one row with 1000 columns, random numbers between -3 and 3. So if I press run right now, one row with 1000 column, all those values is within -3 and 3. That's why it's randomly normally distribution. So this is very important for histogram, and this one condition of histogram, that it has to be normally distribution or normally distributed. Okay, let's keep going. Then I have to call this like figure maybe 1 semicolon. And basically, if I want to plot a histogram, you guys guess what? The function is also histogram. Here we go, histogram plot. And let's for now say data. Let's see what we get. Okay, so as I said, I just want to make sure normally distributed, so it's centered at 0, symmetrical. Symmetrical means goes like up and down as a bell shape. Unsymmetrical, it wasn't be this one, like it will be has out layers, which like most of those tall pens will be towards the right, or which of those two pens will be toward the left. So right out layers or left out layers. And also it ranges between -3 and 3. That's all like function of histogram. And we can apply all the properties that we do apply at any other plot. So let's write like x label, something like value, maybe font size 15, y label, frequency, same thing, font size, title, histogram of normally distributed data. And I think it's very important to make a correlation between the normally distribution and the histogram because they are actually relevant to each other. Font size 15. This will make our plot looks way like more defined. Okay, but this sweet for like plotting a histogram, but histogram has a powerful property and I wanna discover it today with you guys. So as we said, as I said before, like MATLABs can always give me an options of everything, and as I said, every function has different option. So today I want to discuss normalization. So what normalization means with the histogram? Normalization, it just controls how the y-axis value are scaled, and depend on how the y-axis will be scaled, it of course will impact or like affect my histogram. So like count this is the default one. So if I press run right now, count it just like give me the numbers, numeric values for y-axis, like count just number of data points at each pen. Pen is PYN, which means like each column of this is the rectangular one. Okay, this is called pen. So yes, so normalization, it will make my y-axis it just like values or numbers. Okay, one more thing about that, also like it's from the options, it's called probability. Okay, what means by probability? I'm gonna turn my y-axis to percentage of the total data, and this is very very powerful. So right now if I press run, here we go again, like it gives me 0.02, like 2%, 4%, 6%, 10%, and so on. So it just, this is very powerful if you want a relative frequency. And also like if you, it has a lot of application, like you can use a probability with histogram, like for example stocks, depend on like how stocks increased or how many percent, 4%, 3%, 2%, and you can like instead of these numbers you can just like put labels or like different stocks and compare them to each other. So you can do this by probability because they're gonna give you the percentage in the y-axis. That's awesome. Okay, what else we can use? Okay, here is kind very relevant if you are studying engineering or like finance or like application engineer. BDF is not the program apparently. It's just something in the statistics, okay, called probability density function, and it's also very relevant to MATLAB. What this means? Okay, step by step. So it just does it scales the height of each bar to make the total area under curve equal 1. So what means the total area under curve equal 1? Basically or simply, it just makes the y-axis ranges between 0 and 1. It's very important, and like you can use this when you are comparing histogram with different samples, or you want to compare two histograms together or two data set with each other. So using probability density function will be very good because it just makes the entire area under curve equal 1. So gonna make it very obvious, like presenting wise. And also statistical modeling, as I said, because it will help you to understand the shape of your histogram more. So let's try to run it. So yeah, it's between 0 and 0.45, which is still 1, and like it's still like between 0 and 1, and it does give me like little bit presentation or like help me to figure out how my figure looks like. So it's powerful of comparing data or any like type of modeling in general. And PDF, please take notes of this as we go because you guys just don't know when you can use all of this, but when you have like notes, whether like on laptop or anything, or like comments, all of this you can go back and review everything we do, like discuss here. Okay, so BDF, probability density function. Okay, last option I would like to discuss today, CDF. CDF, It's mean cumulative distribution function. What's this mean? Okay, it just plots the cumulative total of the data up to each pen. Cumulative total. So cumulative or accumulates. I do imagine accumulates as like something can get inside thing. So if I do have water bottles and I'm measuring water, I can use a CDF to measure how the water will be filled inside those water bottles, because it's gonna accumulate inside the water bottles. It came from this concept. So how each data accumulate at each pen. So it also gonna turn my y-axis from 0 to 1, and it just like very useful when you wanna see how data accumulates, and basically if you are like measuring data that could be accumulates apparently, and also like percentile based behavior. So percentile in statistics, it's something like the median or the mean. All of this is under our examples of percentile. It's very like mathematical expression, but it's also CDF. It's important to know that this used for this. So let's compare real quick. So if I want to use the probability density function, I can use it like if I want to know, like for example, how tall are the hills is. Okay, but if I want to use the cumulative distribution function, I can use it to see like how much water has filled in each water bottle. So it's very like different, but everyone is very important to know all of this and taking notes of all of this, because this basically fundamentals of knowing the histogram. The next property I do want to discuss is the pen width. So what's the pen width? So for example, is also very powerful in the histogram. So the pen width, let's see if I wanna, it doesn't give me a default number, but it's usually between 0 and 1. So it's very obvious. I said, like I mentioned before, the pen, it's all those like the column of the histogram, widths. So the widths of how like I can change the widths, whether like 0.5, 1, how long, how small. And basically, a smaller pen width will give me more bars and more details. A larger pen width will give me fewer bars but a smoother like shape. So it's inverse relation. The smaller the width, more bars, more details. Larger the width, fewer bars, and of course fewer details. This is very important for clarity. Like let's see if I want to do like 0.8 pen width. You guys can see less details, right? But if like I want to make it 0.1, huge details, a lot of data. And yeah, I can adjust it as I do, because like it's, as I said, it's very important, like if you are for representing wise, if you want to focus or like emphasize on a specific data, not on the other one.